It surely is a great day to do chemistry, and we are all connected. What's connected to the other two types of problems is this third one. In this one, we are going to calculate the number of atoms if we know the amount of moles of the atoms. For example, the first one that we're going to look at is 17 moles of germanium. So if we write down 17.0 moles of germanium, which is Ge, we're going to set this up without writing any numbers in yet, just our units to make sure that we get everything canceled. So moles of Ge goes on the bottom, and atoms of Ge goes on the top. And that's it. It's a one-step conversion because our moles cancel, and we're left with atoms of germanium, which is what we want. So it's a one-step conversion process. When we look at the periodic table for germanium, the symbol is Ge, and that element is right here. It's 72.63 is the molar mass, 72.63. So when we go back here, what we write in is, actually correction, we don't need to know the molar mass of it to go from moles to atoms. We just know that for every 1 mole there is 6.022 times 10 to the 23rd atoms. So when we're going from moles to atoms, you do not need to look at the periodic table. So when we multiply across the top, 17.0 times Avogadro's number, and again, Avogadro's number is 6.022 times 10 to the 23rd. It gives us a value of 1.02 times 10 to the 25th atoms of germanium. Let's take a look at one more. We'll look at sample problem B. We always start off by writing down our value, 0.6144 moles of copper. Let's set up our dimensional analysis without numbers. So we want the moles to cancel, so we put that on the bottom, and we want to be left with atoms, so we put that at the top. Cross out the units that cancel and circle what's remaining. So we wanted to go from moles to atoms, so this is set up correctly. Now, just like the last problem, we don't need the periodic table. We know that 1 mole is Avogadro's number, which is 6.022 times 10 to the 23rd. And you can abbreviate that with an A period N period for Avogadro's number. And when we multiply those together, that gives us a value of 1.82 times 10 to the 24th atoms. Oh, let's go back a second. I am writing the wrong answer down. It's alright, not the first time or last time that will happen. So everything here is set up correctly still, but the correct answer for this is 3.70 times 10 to the 23rd atoms of copper. The next two problems, C and D, I want you to try on your own. I will give you the answer, but I want you to set it up like I did above. The answer for C will be 5.00 times 10 to the negative 5th moles of Ag. And again, you can pause these to try them to see if you're getting them right. And then the last answer for D, 1.20 times 10 to the 30th atoms of carbon. And one more correction, I told you it wouldn't be the first or last time I made a mistake, but the symbol for tin is Sn, not Ag. The number's correct, but I put the wrong value down. Actually, the whole value. Wow, well, wrong again. Let me get the eraser out, and hopefully you aren't fast forwarding through this too much that you're getting confused. But if we take a look, we have for tin, we have 1.82 times 10 to the 24th atoms of Sn, and then the last one 1.20 times 10 to the 30th atoms of carbon. So those are the two correct answers. Hopefully I won't make as many mistakes as often, but that's how you go through a mole to atom conversion.